In this lesson, we will talk about multidimensional arrays, specifically two-dimensional arrays. This allows you to build an array that has a row and a column structure, much like a grid or what you would see in Excel. When we first talked about defining arrays, we talked about one-dimensional arrays. Essentially, it is a set of variables of the same type that have an index that correlates to a value. So when we talked about days of the week, we had index 0 have the value Sunday, index 1 have the value Monday, all the way up to 6 having the value Saturday. That's wonderful if you have a one-dimensional set of data, a one-to-one correlation, but sometimes you have more than one dimension in a data set. Let's talk about student grades, for instance. If we had one student, they have multiple grades or multiple assignments. Let's build an array here. Int grades, let's call them student 1 grades equals, let's say there are 2 assignments, 1 quiz and 1 test. Let's say they had a 12 out of 12 and a 25 out of 25. This represents one row in a table. If this was you would, in this class, you would only see your grades. So one dimension of data is good enough for that. If we were to display these on the screen, we would have a for loop. We'll do a for each. Int grade in student 1 grades. Console.writeLine grade, and we would write these grades to the screen. So here we see 12 and 25 written to the screen, using a for each loop, iterating through each grade in the one-dimensional array. But that's from your view as a student. Let's look at my view as a teacher. One row of grades pertains to you, but I may have 20 students in the class, so I have 20 different rows that I have to deal with. That is a multi-dimensional, or in this case, a two-dimensional scenario, where I have 20 rows, each with 2 columns of data. If we look at Excel, and we used Excel in our first lesson, you can see how this differs from the original array we created, where each index had a single value. In this case, we have 3 students and 2 assignments, 1 quiz and 1 test. This represents 3 rows and 2 columns of data. In order to access a specific element in C#, it goes by row and column in a two-dimensional array. So if I wanted the first quiz from student 1, I would access that data through the index 0, 0. That would be the first student's piece of data. When I'm accessing data using what's called a rectangular array. Now we'll talk about another type of two-dimensional array in a moment called a jagged array, where the column sizes may differ per row. But in this case, in a standard rectangular array, the data builds a rectangle. For every row, there are the same number of columns. In this case, I have 3 students, each with 2 columns of grades. So how would we build this into an array using C# programming? To build a rectangular array, you use a slightly different syntax when declaring your variables. Let's remove this loop, and I'm going to copy the data over from Excel so I know what I'm putting in here. So here's the data that I will be putting into this array. Let me align it real quick. So this is how I want the data represented in the array. In order to build a multi-dimensional array, in this case, a two-dimensional rectangular array in C#, I'm going to use a special type of syntax to define the array. To do this, I'll delete my initializer here. I will declare this will be an integer and an integer array, so I will do an open square bracket, and I will put a comma and then a close square bracket, and I will name this grades. Now there are two ways to define this array. First, I will use our standard new syntax, new int, and in here I know that I will have 3 rows and 2 columns. This will be what's called a 3 by 2 array. Again, the syntax is slightly different, so in declaring the variable's type, you put a comma between the 2 brackets, and then initializing the variable using the new syntax, I put the limits of the rows and the columns. Next, let's add values to this array. So int, if I want to set, grades, if I want to set a value to grades 0, 0, which will be student 1, quiz 1, I will access it through the syntax 0, 0, and set that equal to 12. If I want to set the test 1 for student 1, I will use grades 0, 1, and set that equal to 24. The same goes for student 2 and student 3. Quiz 1 is column 0 and test 1 is column 1. Student 2 is row 1, comma, quiz 0, item 0 equals 10. Grades for student 2, which is index 1, test 1, which is column 1, equals 25. Student 3 is index 2 for the row, and 0 for quiz 1 equals 11. And then student 3, the row index is 2, and the column index is 1 for the test, and that will be equal to 20. Now that I've saved this data into the array, how do I display it onto the screen? Well, we can use a for loop, or we can use a for each loop, just like we did before. Let's start off with a for loop, since we know our limits. Now, because this is more than one dimension, in this case 2, we need one loop for each dimension. Now, you will learn as you get more and more dimensions in your array that you will need more nested loops. So in this case, in order to display each assignment for each student, you need to first iterate through the students, and for each student, iterate through the assignment. So we will type for int student counter equals 0, student counter is less than 2, there's 3, student counter plus plus. So we've created a for loop, and inside of this for loop we need another for loop, because for each student we're going to access, we need to access each assignment. So for int assignment counter equals 0. Assignment counter is less than 2 because we have 2 assignments, so 0 and 1. Assignment counter plus plus. Now, inside of this for loop that is inside of the other for loop, we can display each essentially cell of the array. So here, console.writeLine and we will write in student, we'll do string interpolation, student index equals student counter and I will continue this using the string concatenation syntax of plus on the next line so you can see this in the video. Assignment index is the assignment counter and the grade will equal grades and here we will do student counter comma assignment counter. The student counter represents the outer for loop, which is the row, and the inner for loop using assignment counter is the column. So in this case, we will see 3 by 2, so 6 assignments written to the screen, 2 for each student. There are 3 students. So let's run this application. So here, let's compare this to the table. Student index of 0, their assignment index 0, their grade was 12 on quiz 1. Assignment index 1, their grade was 24 for test 1. For student 2, index 1, assignment index 0, quiz 1 was 10. Assignment index 1, test 1 was 25. Student number 3, index 2, assignment index 0, which is quiz 1, the grade is 11. And for assignment index 1, test 1, the grade is 20. So again, when working with multidimensional arrays, you need to be sure to have multiple loops in order to access data. Now again, if we didn't want to show the counters, but rather simply wanted to show the array values, we could use a for each loop. However, you lose the information regarding the position of the data. So for instance, we could do a for each loop for each int grade in grades console.writeLine the grade and run this application, and we get all the numbers back 12, 24, 10, 25, 11, 20, but you lose the explicit context or the indices that these are associated with. So you could use a for each loop, but you may not be 100% certain that score 25 correlates to row 2, which is index 1, column 2, which is index 1. You just know the value is 25. So for each, in the case of a multidimensional array, iterates and displays or captures each member of the array without context. So when working with a multidimensional array, you want to be sure to use for loops. There's another way to define and initialize multidimensional arrays. In the terms of a rectangular array, in this case, we don't necessarily need to use the new syntax. we can use the same squiggly bracket syntax we did before. And in this case, you use nested squiggly brackets. So we know we have 3 rows. So we do 3 rows of squiggly brackets. And in these rows, we specify the column data. So here, for row 1, we have 12 and 24. For row 2, we have 10 and 25. And row 3, we have 11 and 20. So now we could iterate through all the data. Let me back up a bit. I'll put that back in there. I wrote that wonderful for loop before. Don't want to lose it. So here, once again, we've defined int grades. We can go ahead and get rid of this. And we've saved a significant amount of lines by simply using the array initialization syntax. But we've nested the initializing brackets to represent the amount of rows and the amount of columns. So if we run this application again, we will see we get the proper results. We've just initialized the array in a different way. So let's talk about jagged arrays for a second. I'm going to get rid of this for loop, and we'll use this a similar initializer, but let's just get rid of everything. Let's say that we have a store, and we have 3 items. Or 3 cashiers. Let's go with 3 cashiers. And we want to track each of those cashiers' performance during a day. So we want to create an array of sales. Now, cashier 1 might have sold 1 item for $12, 1 item for $10, and 1 item for $6. Cashier 2 could have sold 1 item for $3, but nothing else. And cashier 3 may have sold 1 item for $40 and 1 item for $7. So the difference here is we have an array. It has 3 rows, but there's an arbitrary number of columns. This is not a rectangle if you were to graph it out. It is what is called a jagged 2-dimensional array. So the way for defining a jagged array is a little bit different. We cannot use the comma syntax in order to define the array. Rather, we have to define arrays within an array. Now it's a tad bit more complicated than a rectangular array, but it is achievable here. So we use, these are integers, so we use an int, and we use an open and close bracket, but then we use another open and close bracket. There's no comma here. So we will call this sales. And in order to initialize this variable, we'll use the array initializing format we used with an open and close bracket. But this is going to be slightly different. So instead of nested squiggly brackets with another squiggly bracket, it will be within each squiggly bracket a declaration of a new integer array with squiggly brackets. So here, cashier 1 would have sales 12, 10, and 6. Cashier 2 would have an integer array with just sales 3. And cashier 3 would have a new integer array with sales 40 and 7. Now this is an example of when we talk about reading the data. one of two ways. You could use for each, or you could use count, or length of the array. In jagged arrays, we may or may not know how many columns there are. So in order to determine that, length is often used when iterating and displaying and using the data. So here we've defined the sales array, we've input values into the sales array, and now we want to display it to the screen. So let's use length in order to do this the right way. So for int cashier counter equals 0, and we want to continue this loop while cashier counter is less than sales dot length. Now again, sales dot length represents the first dimension of sales, so how many rows there are. And then we want to continue cashier counter plus plus to increase the row count. Next, we have another nested for loop for int sales counter equals 0. Sales counter is less than, and here's where it gets a little tricky. So we want the column dimension, or the second dimension, but for this specific row. So here it's sales, and we access the first column here, sales cashier counter dot length. So we want the length of the first row in this case, and then the length of the second row, and then the length of the third row, and so on and so forth. So we want the length of the current row we're on. That's why we're accessing it through sales and cashier counter. We want to access the length of that dimension. And then we increase the sales counter by 1. Then finally, if we want to display the data, I'm sorry, I do need to increment this. We simply write to the console.writeLine sales, and this syntax is a little different, no comma because this is a jagged array, cashier counter for the row, and then another open and close square bracket outside of the other square bracket. This is not inside, not nested, sales counter. So we want the current sales, the current row, and the current column to display on the screen. And then above this for loop, let's indicate what cashier we're on. Cashier row, cashier counter. So now we know what cashier we're on. And after this write line, we should probably have some spaces in between here so we're not too confused. So let's use string interpolation in order to add a space at the end. So what are we going to display here? It should look something like this without cashier 1, 2, and 3. It'll say cashier row 0, 12, 10, 6. Cashier row 1, 3. Cashier row 2, 40, and 7. And again, we did this by accessing the jagged array data through two separate references, one to the row and one to the column, each using square brackets. Again, using a nested for loop. So let's go ahead and run this. And let's compare it to our data. So cashier row 0, 12, 10, and 6. Cashier row 1 had sales of 3, and cashier row 2 had sales of 40 and 7. So these are multi-dimensional arrays. I mean, you can come up with numerous examples for where you would want to do this. Maybe you have a grid structure on a plot of land. You have a number of students in class with different assignments. You have sales representatives with different sales during a day. And then you have three-dimensional values where maybe it's I have cashiers with multiple sales per day represented on each day of the week. So you would have a third dimension that represents time. There's many different array examples. I mean, if you want to build a string theory application, maybe you have 13 different dimensions. I mean, who the heck knows? But these are useful for matrix calculations, for representing multiple data sets. And while the syntax may seem odd and unfamiliar right now, it's a pretty standard syntax across all languages and in mathematics as well. So understanding multiple dimensions in sets of data is important. Again, it'll hit you back when you start studying algorithms and searching and sorting, which we really won't get to in this course. But use this as your first step at understanding the sometimes complicated syntax of multidimensional array data in C#.